Hi, welcome back to our third video for 3.3 Rational Exponents. In this example, we're just going to evaluate expressions. Actually, not evaluate, we're going to simplify expressions so that have rational or fraction exponents. And it says, express your answers using only positive exponents. So our final answers, we just want to have positive exponents. All right, let's begin with this one here. So I can see in this expression on the top, there's two powers that are being multiplied that have the same base. They both have base x. So we should apply the product rule. So we'll apply the product rule. So we're going to add the exponents. So 2/3 plus 2/3. And that's all divided by x to the exponent 1/3. 2/3 plus 2/3, that's 4/3 on the numerator. And then the denominator, we have 1/3. This is going to work out real nice. So now we got to apply the quotient rule, which means we subtract the exponents, right? Because they have the same base, the powers of the same base. So we'll have to do 4/3 minus 1/3. That's my exponent, right? They have the same base. Sorry, they have the same denominator. So I can just do 4 minus 1, and I'll get 3/3, which is actually just 1, right? So, which gives me just x. So that one worked out quite nice, actually. All right, for the next one, for B, okay, we have powers raised to an exponent. So we're going to use the power rule for those. I could also, if I wanted to, I could try to write these as my fourth root and third root, but I feel like it's better to do the power rule first. So we'll write that down here. We'll say apply the power rule. So I'm going to have y to the 2/4, which is actually going to be a half. So if we multiply 1/4 by 2, we're going to get a half. So I'll write that here just to save a little bit of space. And then I have my big X for multiply times y to the negative 2/3. Okay, and now that I'm multiplying powers with the same base, they both have the base y, I get to add the exponents. So y to the 1/2, and then it's going to be plus a negative 2/3, so it's actually just minus 2/3. I need to get a common denominator to subtract those. So my common denominator is going to be 6, so I'll have 3/6 minus 4/6. And I end up with this y to the exponent negative 1/6. Okay, the answer says positive exponents only for final answers. So I can write this as 1 over y to the 1/6. Okay. You could also do this for your final statement if you want, but I feel like it's okay to just leave it like that. Okay, I'm just gonna compress these a bit. And we'll move on to this last one. So I can see power is raised to an exponent. Okay, and then this one I just see a single power with a negative exponent. So I'd like to look at what's happening before I kind of come up with a strategy. So I'd like to do power rule for this first, and then we'll go from there. So this is all squared, this whole bracket, even the 5, right? So 5 squared works out to 25. And then I got to apply the power rule for that exponent. So 2 times a half, it's going to give me just x, right? X to the 1. Okay, so that's the power rule. I'm going to finish this up here. It's going to write the rule. Okay, apply the power rule. So this is this here, because the 5 was squared, and then x to the half squared becomes x to the 1. And then my big multiplication symbol, you can use a dot if you want, or if you even just like using the brackets, you could do that too. So instead of me working with this negative exponent right here, I'm multiplying these two. They have the same base. When I add the exponents, I'm going to end up with a positive exponent, so I should probably just leave it. So multiplying these two, I got to multiply the coefficients first. 25 times 4, well, that's going to be 100. And then x to the 1 plus a negative a half, so it's going to be 1 minus a half. That's just going to give me 100 times x to the half. Okay, we can leave that like that. That's a positive exponent, and that's totally fine. Or if you want, you can write it like this. Both are acceptable. Okay, that's it for this example. I'll see you in the next video.